So now students, we will go for our next chapter, that is angles and pair of angles. See, about angles you have learned in the 6th standard. What you have learned? How to draw an angle and how to name it, how to measure it. See, first we will recall whatever we have learned. That is, suppose I draw an angle with 2 arms. See here, I have drawn one angle. These are the 2 rays which are forming the angle, and I name it as BAC. So this is an angle with the 2 rays. Which is the vertex of this angle? You know which is the vertex? The point at which the 2 rays starts. So the vertex of this angle is, of course, point A. Then which are the arms of this angle? The 2 rays are the arms. Say, shall I write like this? Ray AB and ray AC. Because with this ray AB and AC, the angle is formed. But now, how I will name it, or how I will call this angle? It is usually called by 3 names. That is, B is a point on one ray, C is a point on another ray, and so I can name it as angle BAC, or I can say CAB. Why the 2 names? One will start from B, go for the vertex, and then the third side. Of course, that is the second arm. But one will start from C also. What is that? So you can name the angle as BAC or angle CAB. It is one and the same angle. And you know how to measure these angles. With the protractor, you can measure the angle also and write measure of angle BAC is equal to whatever you have found out. See here, this vertex should always be in the middle. What is its importance? See, this vertex to 1, this is the one arm. This is easy to remember. So one arm is A to B, that is ray AB, and the second arm is A to C. So AB is one arm and AC is another arm. This much you know, and you know how to name them also. Because if I draw a triangle like this and have the name like P, Q and R, how you will read this angle? Of course, as P, Q, R or R, Q, P. Okay. Now we will have one more concept about this. Not only the vertex and the arms are the 2 corresponding factors of this angle, but the one is also very important, because when I draw any angle in a plane, that is on a blackboard, there are 3 parts. 3 parts are like that. Suppose you draw a circle on the ground and playing a dodgeball. Then what will be there? One team will be inside the circle, one team will be standing on the circle, and all the other students who are seeing the or observing the match will be on the outside the circle. Okay, this much you know. This is like that only. This is the angle in which some points are in the interior of the circle. So what is the interior part? See, I have a point P. Where is P? I can say P is in the interior part. Where is Q? Q is also in the interior of angle BAC. Remember, only interior is not sufficient. You have to name interior of which angle also. If I say R is a point here, then of course you can say R is in the exterior. So 2 things we want to remember, that is interior part, or you can say only interior of the angle and exterior of the angle. Exterior of the angle. See, Again, I have see S is here. S is in the exterior of the angle. But where is point A then? As I have named A in the exterior, is it in the exterior? No. See, A is here. That is, it is on the ray. So, it is on the angle itself. Okay. So, this is the third part. This is first interior, then exterior, and the third is on the angle itself. Why we are learning this, or why we are making these parts? Because we want to define one more pair of angles in which this interior part plays an important role. So now if I say I have drawn one triangle like this, see just now that, and it is BAC. Now I know that I have an angle BAC in which I will show different points. Here also. See how many points I have shown. I will label it P, Q, R, S, T, U, V and W. So can you name which points are in the interior, which points are in the exterior and which points are on the angle? See, these are the three parts. So I can make in the interior, okay, then of course the exterior and on the angle. Kiva on the arms of the angle you can say. Suppose I write this S name, like one point here I am taking here as X, and I am writing its name in the interior part. You remember that you should not see where the name is written, but where the point is. So you have to concentrate on the point. See, P, Q, R, of course not X. So these are in the interior, P, Q and R. Which points are in the exterior? See, you can have U, V and W. So U, V and W are in the exterior. And which points are on the arms, that is on the angle? Of course, one is B, the next is A, then the next is C. Because the name of the angle is BAC. All 3 points should be on the angle. Two more points are there, that is T and S. So you can classify the angles only by the observation. Nothing other should be done. See, only see where it is and how I can say it is in the interior or the exterior part. Now, just now I told you, we want to define one pair of angle in which this interior and the exterior parts are very important. Now, I am going to draw a pair of angles. See. In these 3 rays are there. Which are the 3 rays? I will name them P, Q, R and S. With these 3 rays, which are the angles formed? Can you name the angle? Yes, I will write the first name as angle SPR. Starting from one arm to the vertex to the other arm. Then the second angle is angle RPQ. But only 2 angles are there? No, the third angle is also there, which can be named as angle SPQ. See, these 3 angles are formed. Out of these 3, I can make a pair of 2 angles. Which pairs can we do? Or these 2 as make a pair, or these 2 will make a pair, or these 2 will make a pair. Okay? There are 3 types of pairs. 1 and second, 1 and third, or second and third. But we don't want all these 3 pairs, and I want only 2 two pairs such that my conditions should be fulfilled. Which are my conditions? The first condition I want is I want a common vertex. Common vertex. Then immediately you will say all three have common vertex, P only. Okay, that is fulfilled. Then the next is they must have one common arm. One common arm. You will say, yeah, SP and RP is taken, one PR is a common arm. When RPQ and SPQ is taken, PQ is a common arm, and these two are taken, then SP is a common arm. Second test is also valid, but see the third one. Their interiors are separate. What do you mean by interiors are separate? That is, no common point should be there in the interior. All, see here, this is the interior part of SPR. This is the interior part of RPQ. But this is an interior part of SPQ, which is common. See now, I will show you the points here. I can mark this is the interior part of this point. See. Okay, so I am marking this as an interior part of angle RPQ. Then I can mark the interior parts of this again SPR. Okay, so this is the interior parts. I am showing with the different colors, so you will remember it how to find out the different. So, okay, so this is the different interiors. Of which two angles? RPQ, this one, where I have shown with these points, and one is SPR, where I have shown them with these points. But what is the interior of SPQ? The interior of SPQ is common. See, both green points are also there, both cross points are also there. So, this will be a combination of these crosses as well as these dots. So, are they separate? So, this is our third condition. Interiors should be separate. Separate interiors. So, you have to insist on this point. So, if the interiors are separate, then only we will call this pair as an adjacent angles. I will write here. This is our first type, that is adjacent angles. So how you will define now? If anybody says what are adjacent angles? Of course, adjacent angles is a pair of angles, is a special pair of angles in which both the angles have common vertex, one common arm and separate interiors. So you have to check whether three of them are satisfied, then only the two angles are said to be adjacent. So in this figure, which are the two adjacent angles? Of course, one and second. These are not the pairs of adjacent angles. So I will say angle SPR and angle RPQ are adjacent angles. Okay? If two different angles are given like this, and I say, see, their interiors are separate. First condition is satisfied. Interiors are separate. But is there a common vertex? No. Is there a common arm? No. Then these two cannot be adjacent angles. See, these adjacent angles also called as a neighboring angles. How the neighboring angles? They are neighbor of each other, having one wall common in both their houses. Okay? So this is an house for one angle, this is an house for another angle, and one wall is common. Generally we have one wall common in the neighbor and of our house, and so they are called as neighboring angles also. Now we will see how the practice set we can answer from this definition. Now we have learned how the points are divided into three parts, that is in the interior of the angle, in the exterior of the angle, and on the arms of the angle. Similarly, we have found out how to find out the pair of adjacent angles. That is, to confirm the pair of adjacent angles, three conditions are given. That is, they have common arm, one common vertex, and of course their interiors are separate. With this information, suppose we have a problem set, and can we answer the questions? Find out. The first figure is there, and they want to know the points are given in the angle AWB, and we want to find out which points are in the interior, which points are in the exterior, and which points are on the arm. See, very easy. This is only for the observation, so I will write directly only these 4 points are in the interior. So R, comma, C, comma, X and N. So surely make a comma so that the points will be separated. In the exterior, see T, U, Q, V and Y. So in the exterior, T, U, Q, V and Y. And which are on the arms? So A is on the arm, W, G and B. So A, W, G and B. Thus we have completed the table. The table means only the bifurcation or the classification of points from the figure. Okay. So there is a second sum, that is, name the pair of adjacent angles. Now we know how the adjacent angles can be fixed. That is, one point, one arm should be common, one vertex should be common. So here is a vertex N, which is common for all three angles, and so we can make pairs of two together. That is, one I will write it as angle BNA. Suppose this angle I have selected. So I can have this also as adjacent angles or this also. So I will write, and of course angle BNC. Similarly, the second pair is angle BNA and angle ANC. See, every time we have written the vertex as common. Of course, you should not have to forget it. The third one. Now with this we have done two pairs. So with this also we can do second pair. So the third pair is angle BNC and angle ANC. Can you have any other pair other than this? No, there are only three pair of adjacent angles, because only 1, 2 and 3 angles are given. Now, in the third figure, see, observe the figure carefully, and we have to take into our mind that three conditions should be satisfied, because our problem is the angle pairs are given and we have to confirm whether the following pairs are adjacent angles or not. So we will find out, is there a common vertex, is there a common arm, are their interiors separate. Generally the problem is not for the vertex, vertex is only same, because M is a vertex for all, so leave it. One arm may be common. Now what you want to find out is the separate interiors only. Check whether it is a separate interiors. See, because first is PMQ. Where is its PMQ? So P is here, M is there and Q is there. So I will mark the angle PMQ. The second with RMQ. See, here is the angle. And you can say that M is a common vertex, where MQ is a common arm. And to find out the separate interiors, check whether the common arm is the middle part and it's on the both the sides non-common arms are there. Then interiors will be they separate. Otherwise, one common arm and on the same side both the two arms are there, then the interiors will not be separate. But here MQ is a common arm, on the either side is MP and MR. So we can say yes, they are adjacent angles. Okay, the next one, RMQ. So next pair is about the RMQ, same. The same angle is there repeated, but the next is SMR. So it is SM and R. So this one is there. See, you can have which pair is common between these two. See, MQ, S, M and R. So one is R, M and Q. So here is an arm, M is common and MR and MR is a common arm. But you can see that here is the vertex, that is, I will again check here. This is an angle RMQ and here is the interior part of it. I will show it by it. And here is SMR. Here is its points which are common. Now you can see that these are the side which is shared by both interiors, and so I will say no, these are not the adjacent angles. So I say MR is common, but on the MR of the either side there are no two arms, on the same side there are two arms, so it is not a adjacent sides. Then the next is RMS, again the same angle, that is RMS, I will mark it double. Then RMT, so RMT, here is the next one. The same problem is there, that is RM is a common arm, M is a common vertex, but RM is a common arm, on the same side there are MS and MT, and so I will say no separate interiors, and so it is not a pair of adjacent angles. The last one, SMT. So I will make a big SMT. So here is our SMT angle. And RMS. So here is again the next pair. And you can see MS is a common arm. On the one side it is MT and the other side it is RM. So their separate interiors are there, and I will say yes, this is a pair of adjacent angles. So now you must have understood what do you mean by adjacent angles, because these adjacent angles will be there everywhere. The next we are going to learn some more pair of angles, but first you will come to mind that is it an adjacent angle also, and then we will find out.